I'm Ryosuke, so I'm a new faculty here in Harvard. So I joined in August. Sorry, wearing for the mask. I still kind of have a cough, so I just kind of trying to prevent. But anyway, today I want to talk about augmented human thought and creativity with the power of AR on AI. Did you record it, or should I record it? No.
It's automatic recording.
Okay.
I think.
Cool.
Yes.
So, anyway, so I've been interested in media and representation. So this is more like my lifelong research interest. And the reason why I'm interested in this one is because I think the media and representation has the power to augment human thought, or in other words, like make unthinkable thinkable. So let me just kind of give you some illustration. So can anyone calculate this?
26.
Okay, and then how about this one?
Yes.
So
That's better.
that's better. Which means that, I mean, like data has been changed. It's actually going to represent the same number, right? And then your brain also hasn't been changed. What has been changed is just an interface for the representation. So meaning that, like, if you have a better representation, you can actually become smarter, and you can actually kind of think better, in a more powerful way. And also, it's not impossible to calculate it, but this is actually a super tedious process to calculate it. And then multiplication is even harder. So this is kind of how I think, for example, media and representation is actually a powerful way to augment our thought. And another example would be, for example, something like that. So before 1786, like people read the data because there's no way to see the data. In 1786, William Plater invented the video representation of the data. And then you can actually gonna see the data. And now we can't imagine the world without the graph. So again, the data is the same, but how it represented can be changed, and it immediately, augment your thinking process. So that's why I'm very interested in kind of media representation, because it actually kind of has that power to make unthinkable thinkable. And especially, I'm also gonna, working on computer science. So I am also interested in how dynamic medium and representation can actually kind of augment our thought. For example, dynamic means that like what you can kind of interact and respond and animate it in a way that computational with a computation power. For example, like when you look at like a very traditional AI paper, like convolutional neural network, you can see the like a representation like that. So this is like a CNN convolutional neural network explainer. But you can actually kind of interact with it based on the input, so that you can immediately understand what's going on in this network. So again, this is the kind of how dynamic interactive representation can actually allow you to explore more about what the meaning of behind it. And another one is also, say, example, like traditional physics teacher can actually gonna teach based on the blackboard or the whiteboard. But say example here, like comparing is kind of demonstrating how like a Chalktalk, which is sketch interfaces that can kind of correspond to what you teach and how it's kind of animating and interacting behind it. So this is the kind of how like a dynamic representation media can actually kind of make teachable, right? And this has actually happened to my daughter a couple of weeks ago. So she kind of tried to learn the piano with that kind of notes, and it never happened. She never learned the piano even for like a month. And then I actually kind of showed like this is one of the apps, like a smart like a piano app. But after that, she immediately can understand like how to learn, how to read the notes. So that is the kind of how I believe like a dynamic media can actually gonna make unlearnable. So my lifelong research mission, which is actually gonna the same since when I was first year PhD, was I want to invent dynamic media and representation to make thinkable and unthinkable thinkable. And I also more beyond that, there are also many different ways that we can kind of untap into the human's natural way of learning, understanding, discovering, and seeing and making in a way that which we cannot do that before. So that is my research goal. But what's missing, if we kind of look at the current landscape of the human-computer interaction or even computer science research in general, what's missing there is there are kind of two aspects. So one is the media aspect, another one is the representation aspect. So this means like a media is more like a book, and the representation is more like a content of the book, like how the data should be represented. So I can see the two main limitations right now. So one is the media. So dynamic media is a kind of very powerful way of thinking, which is the computer. But that dynamic media is actually currently trapped onto this tiny rectangle screen, ignoring the entire physical world. So that really frustrates me. And another one is so dynamic representation, as I showed, is actually a very powerful way to think about it. But these are mostly require the programming. And then the programming, whatever requires the programming is actually gonna, requires a lot of time, like a tedious and time-consuming process for specific purposes. So we can't really expand it to any kind of thing because some random programmer needs to program it beforehand. So we actually gonna need to fit into that realm. So I want to change this kind of paradigm. And so for example, like stepping back a little bit to see how we actually think in the real world, we actually gonna think, like explore in a physical space to kind of walk around, like see around, and kind of discuss, kind of look at from different angles, organize things, and browse the things. We actually kind of naturally leverage, so many kind of physical activity and spatial activity to think about it in the physical world like this. But when we think about the thinking with the dynamic media right now, is just kind of restricted into this tiny rectangle square, ignoring the rest of that. So that I kind of, how to say, currently, you are thinking like computers as more like a tool for thought. But I just want to change this paradigm into more like a spatial thought. So the entire living world becomes dynamic media, and we can leverage dynamic representation to think about it. So as if like a dynamic, we are kind of living in the dynamic media rather than living with. So to illustrate it, I'm kind of calling it like a dynamic spatial thought. And then the dynamic spatial thought is something like that. So for example, like every single room becomes, we can kind of, like understand thing and, reading thing in a natural way, like presenting, discussing, like browsing, discovering, creating and making. So if we have this kind of dynamic media, we can actually kind of leverage and augment our daily process of thinking, learning, and understanding them. So I am very excited about to make that happen rather than just, constrain ourselves into the tiny rectangle screen. But so my research vision is I just want to try to bring this dynamic spatial thought into every single room on Earth. So it's like, oh, I'm serious, actually. So Bill Gates said, like, he wants to bring the computer to every single desk. But I just want to envision that, our every single room should be something like a, science museum, so that you can kind of download science museum and you can actually learn and think in a way that you kind of interact in real world. So one of the problems or one of the challenges is like how to blend the virtual and physical object in a different environment, because such kind of concept has been there over almost like decades since like 1990s, 1980s. But one of these problems is like it only works for the specific purposes or specific location, because it doesn't really kind of, how to say, scale to different environment. So that's why, I believe that we really need to intelligently recognize environment, understand activity, and embed the response into the physical environment. So that's why I believe like augmented reality and AI might be a powerful way of moving the forward. So that's why I'm kind of excited this intersection of this. And in this talk, I want to somehow illustrate what I have been doing in the past, and also I'm gonna show like what I'm trying to do in the next, couple of years or even in the next decades. So one of the aspects what I have been doing is like AI-powered augmented content creation. So as I said, for example, like augmented reality has a very powerful way to learn and understand the concept. Like augmented textbook is all all over there. But as I mentioned, such kind of dynamic representation requires the programming. And then we need to program this kind of content for every single textbook, which doesn't need scale. Because this app only works for specific purposes, specific book. But if we kind of bring another book and it doesn't work. So that's why I have been working on how we can use AI-enabled augmented textbook to augment any kind of textbook or books in real time and on demand. So one of the projects is augmented math, but I can just kind of quickly show you how it works. It's pretty easy to demo. So you can see the so this is kind of more like iPad app. But can you see it better?
Yes.
Okay. So here I have now. So this is actually a physical paper, by the way. So the textbook. So again, I just kind of read it, and then this system using the machine learning to recognize what's written in a math equation. And then by doing it, for example, I just want to, for example, recognize this attached to this a graph. And then, so this is kind of digital overlay on top of it. So I can kind of start manipulating this to see how or this parameter can change, or this parameter can change x-axis, and this parameter can change y-axis. And the problem is, the important thing is I haven't programmed it beforehand. So that one can be recognized and created automatically based on machine learning. So for example, if I choose this one, then this one, and then if I change this parameter, and you can see how it works. So again, this is kind of automatically going to generate it and recognize based on the math equation. And I put graphs on top of it. And then so the user can actually see it to how it responds. So this is a kind of quick overview of the augmented math. So as you can see that, again, augmented math, the goal of the augmented math is makes the math graph interactive without really programming beforehand. So this can be, for example, you can kind of, I already connected this one, but you can kind of see how it behaves based on a parameter change of the real world. And as I said, this can be work for many different, such as showing, breaking down some of the concept, or you could also kind of show the hints of some equation. And under the fit, it's kind of, so this is the kind of broader version, by the way. So you can see that this is the kind of PDF, and if you click the graph, and if you kind of link to this a graph, and then again, as you can see, all a digital overlay show on top of that. And how it works is so once I render the PDF, and it detects this kind of equation by using OCR, and it also detects a graph of the axis and the graph, so that if I kind of show it, and then it can just kind of render on top of it. So which means that I can also kind of show different graphs, so that I can see how these kind of graphs can render automatically and generated. So that was augmented math, and so I'm not gonna go into the detail of the system. So if you have any question, you can just kind of ask me. It's just kind of, yeah.
So this is designed specifically for this content, right?
No, this actually, so it actually kind of works for, for example, so problem is that I just needed the a paper recognition, but for example, this one is you can also kind of use it like a different PDF, a different content as well.
So you find the equation and your software then creates plots and stuff.
Yeah.
Okay.
That's right. Yeah, exactly.
Is it your software, or is the eighth wall a platform that allows you to drive your, because it's like.
Oh, A4 is just only for rendering, like for
For
AR.
rendering,
Yeah. So, Yeah.
And you mentioned AR, I mean, I agree, this is AR.
Yeah.
But you mentioned things.
oh yeah, of course, yeah. I mean, the reason why we use iPad is just only because it's easier to demonstrate it, but obviously we can do that with it too, yeah. Another one is also we kind of try to expand it to the like physics as well, so I can also kind of quickly demonstrate it as well. So again, like this is also like a physics PDF, like a physics textbook, right? And then in a similar way, we want to see like how it behaves by using like a simulation rather than just a static diagram. So in this case, I can just author it, and then if I process it, and I can kind of start simulating like that. So again, like this is kind of what I'm doing it here is like just how to say. So this is a kind of I didn't program it beforehand. What I did is what I did just kind of like a segment from this textbook, and then they apply the physics property on top of it. So which means that I can also say, example, like this is like a lens, and this is like an object, and this is the lens. And then I can also kind of segment it to kind of provide interactive physics simulation by just kind of interactive like open process, again, like without any kind of programming beforehand. So that one is also another way to like how we kind of try to augment into the different field. Again, like this is more like a physics concept, but as you can see that like if we segment it from the textbook, and then we can apply the physics simulation property on top of it, so that we can just kind of start simulating without really looking for the content. Yeah. So yeah. So idea behind it, like a technology behind it, just kind of using like a machine learning model called like a segment management, so we can kind of segment it from the diagram, and then we can kind of apply like a physics animation properties, such as like a looping animation like that, or like a animation like a pendulum, or like a what is it called, like a Newtonian motion type of animation, or interaction, or simulation. So again, like the goal of augmented math and physics is, as I said, I believe in like dynamic representation like that actually make unlearnable learnable. But idea of making this kind of thing is really costly. So we are wondering, what if we can kind of augment any kind of textbook by using AI instead of kind of programming for every single textbook. So that is, obviously, there are so many limitations of this project, but that's the kind of, like a vision of what I'm doing. And obviously, like in a physical world, it's not only about like a physics and math textbook, but we also want to kind of augment any kind of text, any kind of books or the textual representation of the world. So what we did is also kind of trying to integrate a large language model into, as you said, like a glass of, like in this case, HoloLens or the Apple Vision Pro to, how to say, real-time, like a summary and then also augmentation for any kind of the textbooks that you're reading. So idea here is like, what you're reading, when you're reading, like a LLM, like a ChatGPT can actually read what you're reading it by using OCR, and then provide like a summary or like a important information, like a citation, differences, like a table content, so on and so forth, onto your field of view. So this is the kind of how we did for like a reactive summary. So implementation-wise is pretty simple, but we actually kind of, the interesting thing of this one is we actually kind of deploy it into the real world to observe like a week-long, like a use cases of such kind of interfaces. So how we implement it is, again, like by using the camera, we capture the document, and then the OCR, which is kind of extract the text onto the document. And then we use like a GPT-4 to summarize it, like a timeline, and give a list and grasp some kind of, visual representation. And then we show it, we showcase it around the document in AR. But again, like a technology is pretty simple, but we are interested in like how it can be scaled and how it can be usable in a daily environment. And one of the interesting find we are kind of submitting to the CHI right now. It's been almost like 2 years of the project, but one of the interesting finding is they also kind of start trying to apply to not fields. But for example, like go to the cafeteria to look at the menu, or like which one is the vegetarian menu, for example, or like which one is the, like healthier like products, or like a kind of translation. So there are many kind of interesting experiences, if we kind of tap into any kind of documents and by using LLM. So that is a kind of interesting contribution from the HA point of view, I'd say. So again, like this point, like system is not the goal, but like how we learn from these kind of actual deployment experience would be kind of important aspect. Anyway, so that is a kind of one of the aspects of how we can kind of leverage AI to augment the content without really manual programming. And another, oh, by the way, so this, we actually gonna showcase only like 2D thing, but we are obviously gonna won't stop at the 2D. We actually kind of trying to develop some kind of 3D extraction. And what if, you are leading the dinosaur route, and then what if, dinosaur comes out and kind of walking around, that'd be really cool. There are also kind of many technological challenges, but we are also kind of trying to do that too. Yeah. So that is the kind of first aspect. And then the second aspect is also kind of we try to leverage and make tangible augmented reality interfaces more ubiquitous. So for example, let me showcase it. If you want to, so here's kind of virtual core, right? And what you want to do is just kind of try to grasp some kind of random physical object and use it as like a steering wheel, for example. So to make it happen, maybe you can think about, okay, you need to attach like a sensor, you need to attach a sensor, kind of Arduino, that kind of thing. But it doesn't scale, because you cannot really embed a sensor or the markers to every single object of every single room, right? So that's why like we kind of trying to we try to do the kind of teachable reality, which is augmented interfaces by using interactive machine teaching. Again, I can also kind of quickly show you the very simple demo. So, for example, I just a kind of very simple. Okay. Just a very simple application, but let me think about it. Okay, like I want to use this as like a slider. So if I think about like if I move it like this kind of hand, and then like a 3D virtual object can become bigger or something like that. In that case, instead of attaching marker or sensor, I just kind of demonstrate to train like a computer vision model right now. So here I just kind of provide like 3 different types of stuff. Okay. 3 different types of like a model right now. So right now, like a system can recognize like a 3 different, how to say, category. So in this case, I want to just attach, okay, 3, okay, and then I gonna just, okay, like attach this one to the first model, and then make it bigger, and then the second model, and then make it bigger to the third model. And if I cannot. Okay, and then you can kind of, make that kind of interactive application, just kind of using like a simple demonstration, right? Yeah, something like that. So again, like this is just a very super simple because it's kind of a little bit too messy outcome. But again, like this can be work for any kind of the computer vision, model, because you don't really need to attach like a sensor, but you can actually kind of demonstrate it, and so it can be used for many different purposes. So that is the core idea of the teachable reality. So again, like by using like an interactive machine teaching, machine learning to demonstrate the activity or demonstrate the interaction, And then by using that, if you just put into the AR, into this interactive activity, then you can kind of create this kind of working prospect rather than like a mock-up. So I just kind of skipped this one. So we somehow explore many different types of application scenarios, like using like a physical object to manipulate interfaces or context-aware systems or the paper or body-driven experiences. So yeah, I'm gonna just kind of quickly go through it, but as you can see that you can just kind of try to use it as like a prototyping tool or demonstrate it to make some kind of interactive augmented application by using a physical object and a physical body. So that's a teachable reality. So we kind of trying to, again, like the goal here is we want to transform everyday object, everyday learn into like AR interfaces. But that was kind of hard because you need that smart car or the sensor. So we kind of try to leverage like a computer vision model on top of it. So teachable reality is only about just kind of very simple, animation, but we are also interested in like how we can parameterize and visualize the real world motion as well. So, or again, I can just kind of quickly show you another them too. So like this is a kind of reality sketch. So it's a kind of sketching interface in augmented reality. So for example, sketching interface means that like if you like draw a line like that, I'm just drawing one like here, then you can kind of draw into the physical world. So it's attached, right? But idea here is like it's instead of just kind of static drawing, again, like I can just kind of manipulate it, and whatever you draw can be kind of dynamic, right? So meaning that like if you draw like that, draw a line like that, and draw a line like that, and then everything can be like a dynamic kind of parameter. So idea is, once we have this kind of the parameterized the real world, we can kind of start using these parameters into an object. For example, if I have like a dinosaur model here, for example, just kind of random thing. And then, okay, if I attach this like so this parameter should be like a dinosaur size, and then I can kind of.
Where did the dinosaur come from?
Oh, that one's gonna have. That's gonna use it. Like yeah, this is just only for like a quick demo. So, but obviously you can kind of choose it. Like there should be some But yeah, so this it's just like a angle, and then you can kind of rotate it. But it's not only about kind of connecting, like binding the parameter, but you could also kind of visualize it too, right? So, for example, like so I define this angle as a main dyno model, a dyno angle. So if okay, oh. Does that work? I'm sure. Okay. Computer vision model that is really frustrated. But anyway, so I'm gonna put here as like A, and then if I just wanna, Y should be like A, like a bind it again, and then you can also kind of bind it to see like how the graph looks like. So again, like everything is kind of parameterized and binding so that you can kind of visualize the real world motion by just kind of using like simple sketching. So, well, this was a kind of simple, simple demonstration. But as you can see that, like, here we wanted to make like a sketching interfaces as a dynamic. So instead of a sketching, static sketching, we can kind of, like visualize it, real world motion, so that if you just attach into the sketching, and you can actually kind of interact it in the real world. So that is the kind of goal. So yeah, for application purposes, it can be kind of used for some like a classroom, like education or demonstration in the real world. Again, like a teacher doesn't really need to work on it, but you could also demonstrate some kind of mathematical like concept, like an angle between two gears, or like showing like a visualization onto the body movement, And also, again, I just demonstrated, you can use it like any tangible objects as the user interfaces by just kind of quickly define. So that was kind of like a sketch-based like a parameterization and a visualization of the real world motion. And I gotta just kind of quickly skip this one, but kind of similar idea that you could also draw some kind of freeform sketching. So it's not really limited to just like just a line and an angle, but you can actually, freeform sketching or simply like quickly create this kind of AR interaction. Just a quick demo. So that, but using I like sketching because it's kind of very improvisational way to create many different applications, and also like kids can even like sketch it. So I guess I think that's why I believe it, because sketching is one of the kind of powerful way of representing an idea, and kind of dynamic way of representing an idea. I can skip that. So so the second theme is about like how we can kind of make the tangible interfaces more ubiquitous, like by using like AI and machine learning driven approach. And then the third trajectory is about how we can also like augment our daily life conversation and communication in general. So right now, I'm kind of presenting the idea by using this kind of, like a slide, but we don't really have to stick with this kind of slides type of representation media, right? So that's why like we are also interested in kind of how we can AI like augment our daily conversation, presentation, and communication in general. So so I have been working on like a presentation and conversation aspect for a while. So I just want to quickly showcase like what I did for like presentation. So what I mean by augmented presentation is something like that. So this is the kind of famous Hans Rosling like a data visualization, like a storytelling. But as you can see, like this is kind of using like his own body and then kind of embed this representation into the physical world. So that is a very powerful way to present idea rather than kind of using just a slide. So I'm really interested in this kind of augmented presentation. But obviously, one of the problems is like this is by the video. So it requires a ton of like a time of the video editing. So it requires a lot of time for the programming and video editing. And then also, more importantly, it doesn't work with the real time. So I am interested in what if it works with like a real-time conversation and a presentation. And then, so example, like this is just like a first prototype which we made.
Hi, my name is Mehrat. I'm an undergraduate student at the University of Calgary. Today, I want to talk about augmented presentation. As you can see, when I talk about something, we can augment the presentation using an augmented reality interface.
So as you can see, like this is a kind of very simple demonstration, but you just kind of by recognizing what you talk and then you embedding the representation on top of it,
and
actually kind of makes the powerful way of
all components are interactive with
and so to do that, we first kind of trying to look for like a 300 of the video of the augmented presentation to understand like what are the kind of common practices and technique for these kind of video types, video-based augmented presentation. And then we kind of categorize it like the common types of the interaction. And then based on that,
Hello, class. Today we're going to discuss white blood cells.
We created
and killer T cells.
Kind of, presentation tool.
In particular, we'll talk about the HIV virus
so this can
and
be
how
used
it attacks the blood cells
and
hides from the T cells.
Is like a zoom in,
we can see this displayed through this diagram of the immune system.
We are interested in like how we can kind of make the teaching.
Now we're going to show a quick video demonstrating this process.
Engaging and interesting. And
Hi everyone, I'd like to introduce this new water bottle. It has
purposes.
so many benefits, including double wall vacuum insulation,
Like
its
TikTok
flexible
type of,
perforated handle for easy
video.
use, and it's dishwasher safe. You can bring it with you to so many different activities, including going to the gym, you can bring it to the outdoors, and if you'd like, you can even bring it to the pool.
yeah, so that was the kind of presentation. And I also, yeah, I also did a conversation too. I probably gonna skip it, but the conversation is something. So, obviously, we can kind of, how to say, we can like the same thing. We can just kind of like track what we say, and then kind of get keywords and then, put them some kind of video references. So nowadays, this was kind of 2021, 2022. So nowadays, like with AI, it's much more, we can probably do much more than that. But I'm also interested in like how we can leverage it to kind of deploy into the real world to get more insights in the real world. So that was the kind of, yeah, so these kind of three aspects are the, yeah, like the trajectory of what I did in the past. But I think the more important question is what I'm going to do in the future or in the country when I'm doing it. So I just gonna try to spend some time to like showcase and talk about what I'm interested in and as a lab and what I'm also personally kind of trying to do that too. So again, like to go back to my original goal is like invent dynamic media and representation to make unthinkable thinkable. And then, as I said, like I think there are kind of two aspects. So one is we need to invent a media to leverage entire physical world rather than focusing on like a tiny rectangle screen. And the second one is a representation, making representation hard. So how we can kind of make static representation to dynamic or any kind of thing. So what I'm gonna do is probably gonna kind of continuously doing it. But first one is I just gonna, so I kind of trying to make like a platform that I can use it for everyday life. So most of these kind of programming tool frustrates me because I cannot really use it for my own purposes for everyday life. So it's more like a kind of demo for the research. But if I believe in this kind of tool can actually kind of make me smarter or augment that thought, I actually gonna need to use it and I become smarter and I can, my research lab is gonna be more productive. So that is the kind of one of the goals for my next couple of years or next 5 years, for example. I just want to kind of try to make a platform and then use it in our lab every day. And then we also gonna ship it, like distribute it into the world. And the second aspect is, which is more like my students have been working on it, is like a AI. I think the kind of AI is a very powerful way to like changing the representation from static to dynamic, or like a 2D to 3D, or the passive to interactive. So for example, my student is working on it. What if you are kind of watching a video in a one directional way, right? But what if you can kind of start asking a question to the video, and then the video is kind of start responding to you, like a Harry Potter way, right? For example. But that is actually kind of possible, because you can kind of generate like a video response and kind of embed it into the video, right? So this is the kind of one of the examples, like how we can make like a passive content to the interactive. Or currently, ChatGPT only returns you by like a textual responses. But what if we can kind of change the textual response, textual representation into like a spatial or the video representation, so that for example, if you ask a recipe, then you can kind of recognize like what you have in the ingredients in here, and then you can kind of add some kind of annotation in the physical world. So again, like this is not, the vision here is we don't really require like a programming for every single aspect, but we can actually automatically generate like a transform this representation content. So that's kind of where I'm doing it. And then I'm gonna quickly talk about like what I envision for the first one, which is like AI in the room and AI in the loop programmable environment. So I am kind of thinking about this kind of environment. So here is, you are kind of living in a physical world, but again, like for my own purposes, I want to program it. I want to kind of make it dynamic without real limitation. So for example, think about it, if I just kind of select this object, and then I'm gonna start programming. For example, like a show the hello world, and then I show the like a clock, and also like a change the color when you touch, right? So again, like this is a very simple program, but if I do it, and then immediately change it, and then if you touch it, like changing, and then the like clock is also kind of like a rotating, and then I could also kind of augment any kind of physical object. For example, here I can program this object and okay, I can change the color from like a blue to red. And then I gonna grab another object to, okay, like use it as one kind of parameter for this object. And then if I just kind of start connecting it like what I did, and then I can just kind of start changing the environment. And then if I can kind of make every single object as a programmable, and then by using a ChatGPT to just write the program on behalf of me. So if I say, okay, like draw some kind of ball bouncing animation, and then I can kind of start using it. And then if I also kind of program it, and then I can also copy such kind of instances into the kind of different instances, different objects in a physical environment. So that's what I mean by like an AI in the loop, like AI driven, like a programmable environment. And then because if I have this one, and then we can actually use it to like a prototype and demonstrate it during the meeting, rather than kind of go back to your home and to work on like a 1 week or 2 weeks to work on it. So I'm not sure it's actually going to work in here, but I can also kind of just quickly showcase it. One of my concerns is if I can actually going to use this camera on let's see. Okay.
Ready,
Okay, that's fine.
you can change it back on your
Hold
Zoom.
on.
Okay.
Yeah. What is behind that? Yeah, I think, okay, what about if I,
That's changing for the Zoom call, not for the app.
yeah, I think so, yeah.
You can.
But in Chrome, you can select what's the default
No, I probably gonna need to
You
change it.
can change it all.
Yeah,
manage.
I think it's good.
Okay.
But anyway, if I just wonder if it actually gonna work in this.
A lot is happening, right?
This is so. I can.
yes.
Okay, so
But isn't-
I can, okay, like a say example, I just gonna quickly like draw a ball or something like that, and then it's trouble. Then really?
Oh,
Wow. Okay. But anyway, I can probably gonna demonstrate it later. It's almost like a ton of time. But what I'm doing is actually gonna using, yeah, kind of like a prototyping system to make it happen, so that I kind of just kind of, you know, kind of like trying to deploy it into my lab. And either it's using like a projection mapping or like a mobile AR or the headset. It doesn't matter because it's more like we are kind of making more like operating system level. And then we just kind of use it in the everyday life, so that most of these demo, like most of these projects can become more like just obvious or trivial. You know, it's not even become a research project, but we can actually gonna test it and experience it in minutes rather than weeks. That is my goal. So that's the kind of what I'm doing it. And then also in terms of the kind of REST aspect, as I said, like, you know, you can kind of leverage some. So these are like just kind of concept videos that we are doing it. But so for example, this is what I meant. This example, like, you know, if you ask like a ChatGPT about like a recipe, instead of kind of responding in a textual way, but you can also kind of embed into the spatial manner, right? So if you, for example, you kind of recognize like often, and you can actually, you know, like show the week, show the timer, something like that. So again, this is a kind of textual representation to spatial representation. And then we could also kind of leverage this kind of large language model and context-aware large language model to embed these responses into the physical world. Yeah, like what if, you know, you can kind of translate like a sketches into like a dynamic representation, like in this case, like a mind map, for example. And then again, like we could also kind of transform the entire environment, so that, for example, like by using like generative images or animation, you know, we can kind of start, you know, doing this kind of content transformation in real time. And again, like for the presentation aspect, for example, this is just a quick demo about how I use it, like a reality augmented presentation with a headset. But by just kind of playing it, it can summarize it and create like slides so that how it can be used for like a presentation and conversational support, so on so forth. But anyway, I'm probably gonna just stop here, but this is kind of how I am interested in for the future of the research. So this is kind of next 3 to 5 years of my lab, and especially like that one is gonna be my probably like a second PhD dissertation to make it happen and actually ship it. And then in the next 5 years or even like 10 years, if like hundreds of the different places, like a classroom or lab or the makerspace, use my system, that video is great. That's it. So thank you for coming.
I didn't check your slide.
Yeah, I did modify those. Yeah.
So, I mean, I love this, first of all. Secondly, I mean, there's infinite applications. And what I'm seeing is most of your stuff is kind of demonstrative right now. So, we can do this, we can do that, all these different tools we can develop.
Yeah.
Have you thought about any, sort of real killer apps that you
Mhm.
might develop in a certain application
Mhm.
domain?
Mhm.
Where with success with that, like
Mhm.
medicine or cinema, entertainment, gaming,
Mhm.
lots of different things.
I think, I'm personally interested in education line.
Educational.
yeah.
I'd say,
Yeah. So the part of the reason why I'm kind of developing an AI room is I also kind of transform the classroom as well. So like AI classroom, for example. So that kind of in the same system, kind of working in the same way, like a teacher that, like everything can be programmable, so the teacher can do anything. But again, like a teacher doesn't have to be, by using an AI to just create a dynamic representation, in the real time. But again, this is the kind of like classroom experiences, as well as kind of personalized learning aspect as well. So for example, we kind of use like augmented math and physics as more kind of personalized learning, how to say, like an enhancement, enhancement. So, and it's also kind of, how to say, that's kind of one of the exciting domains that I'm interested in, especially for the first domain.
That makes me think of all the opportunities for a handicap for learning disabled.
Mhm.
That's really exciting.
Yeah, definitely. Yeah, and I'm personally, I have 2 kids, so if they can actually start using my own system to learn something, that'd be cool.
Can you go back to the slide of like where it shows, I think it's your first or second slide, shows the classroom, that sketch idea that
Like
that one?
Yeah.
So what is the hardware interface and all this? Are they all wearing goggles, or is there a screen on the wall that they're looking at for the augmentation?
So I intentionally hide it because the technology evolves. So currently, I think so I personally like a projection mapping, like a projector. But I cannot really control, for example, like what Meta or the Apple will, release like next year. And then I cannot also kind of control the trajectory of the society adaptation to it. But again, either way, I think I can probably gonna do the same thing in general. So so that's I mean, in the short term, maybe it depends on the situation. For example, in a classroom setting, it's not really realistic that every single student and the teacher wear the glasses.
Right.
So maybe the projection mapping type of approach works. And maybe the lab too, right now with the current hardware. But I'm also kind of comfortable kind of wearing the label meta glasses.
Right.
So in that case, for example, if that kind of form factor becomes like a readily available, and then maybe kind of situation might be changed.
Yeah.
But I'm more interested in, so for example, I'm not interested in inventing like an iPhone, like a screen, like an iPhone touch screen. I'm more interested in what we can do with a touch screen become ubiquitous, what kind of media and representation happen. rather than kind of focusing on, oh, I want to invent a touch screen. In the same way, I'm not really interested in kind of developing the kind of glasses or the projection mapping itself, but I kind of trying to, so that's why the an AI RIM idea is whatever kind of, for example, AI model also kind of, evolving, recognition model is also evolving. But regardless of that, if we can kind of make this kind of experiences, that's like more kind of what I'm interested in, what I'm focusing on.
Cool. So the glasses you're mentioning are probably less than 10 years away.
Yeah.
In terms of their, there's wireless protocols and battery power.
Yeah.
Those are the main issues, and as well as the display.
Yeah.
Okay, but I think it's less than 10 years.
Yeah, but Meta Orion is also kind of looks promising. I haven't used it. Yeah, like a Meta actually didn't release it, but it's gonna showcase the prototype of the glass level of the 3D thing.
Well, Daniel has a question. Daniel,
Okay.
Papa.
Is it easier if I what do you say? Unmute myself?
Yeah.
Okay, so no, I was just wondering, I think I want to push back against that, your point, because isn't it like most crucial to think about how people interact when you design these interactions? Because I mean, you're literally talking about how we interact with an LLM. So then you also need to think about how we actually do that. And I think without really considering the hardware, you're missing out the most important piece. I mean, when you're talking about your space here, it's a huge difference if people use glasses or projection mapping, for instance, because we're talking about multiple people and sharing information.
Yeah. Yeah, no, I agree. So that's why I said it depends on the application and the situation too. Yeah. So I don't really think that like a one size fits all type of thing. I mean, like we probably gonna need to have kind of different again, like most of these kind of application level, yeah, it's kind of depends on the hardware. But what I'm mostly talking about, like what I'm doing right now, like about like a real world wide web and AI room. So this should be more like a technology independent, yeah, because it doesn't matter like whether we are using it. Again, like a projection mapping cannot do it with the 3D, but like a glass can do 3D. So these kind of these aspects have actually differences, but again, like it kind of I feel like it depends on the application though. Yeah.
I mean, what I'm saying is, of course, it depends on the application. That's, but what I mean, I love hardware and I love physical interfaces, and that's why I think if you present this dynamic space for thought, you obviously can't just say things are going to happen and it depends on the application. You have to say, no, where is the data actually going to be and how are we going to share it? And how will we build that? And it's not just like, oh, we're going to use the phone or we're going to use the glasses or we're going to use the projector. No, what are you actually going to use? I think is very, very important. And I think you have a lot of thoughts on it, actually, that you're not like that you should be sharing because you've thought about it time.
Yeah. I mean, like I personally, okay, I am personally liking the projection, but more realistically speaking, I guess like a glass type of hardware, probably the more realistic, yeah, in the long run, let's say. Yeah.
Thank you.
Yeah, one more questions?
Oh, hi. I have some question for AI model. Yeah, it's kind of usability question. So how you do persistent storage? Because people definitely wanted to save point and load the thing again. Like you just believe like storage will cheaper in future. Or, yeah, how you consider this point?
So that is more like a system design level. So for example, like if we just want to store thing, we just only have a hardware, we just only have like a database somewhere that we just gonna store it, right? So idea here is I am just gonna trying to get inspiration from the web architecture. So the web is, again, like it's more like a decentralized, you know, like if you go to the if you go to the same URL, you're gonna get same like a same video representation. So that is I feel like a storage is more like something like that, right? So if every single object from your point of view has an ID, right? So like this has an ID, like this has an ID. Like every single object can have an ID similar to the URL, right? And then like, you just kind of load it, and then you can see the same object, you know, same representation. It's not really kind of ephemeral thing, but we can kind of, it's more like how to say, like here's a video representation, and here's kind of physical object. How we can map between it. So that
Yeah.
makes sense.
Oh, also one more small question. So you have like you have argument presentation for audience, then to chat. It's yeah. For chat, it's like a double direction between presenter and audience. And another. Do you imagine like just for presenter like something to help presenter control the time, or like make or some reminder things.
Are you talking about a specific project or
Yeah.
like a presentation tool?
Yeah, presentation. Like where you skip to the.
This one?
Yeah.
Okay. Oh, this specific tool is kind of like it's simple. Like it's just kind of using a webcam, and then you just gonna how to why you manipulate is what you see. Like you actually gonna see you can actually gonna see what you're doing, and just gonna using camera. So does that?
I think it's targeted to audience.
So okay. Yeah.
So
this one is more like a video based like a presentation. It's more like a Zoom type of thing. So it's not in person. Does that make sense? Yeah. But again, like as I demonstrated, you know, if I can, again, this only works for the video, like a Zoom type of the lecture. So if we actually gonna need to use it in an in-person lecture, like this one, maybe I think that hardware could be different too, right? So that's why like I demonstrate like a glass type of thing and kind of show the content in general.